Remember that when graphing two lines, well, graphing two linear equations, either they will intersect, it can intersect in a number of ways, or they're going to be parallel. We know from algebra that parallel lines in geometry, they don't cross. In algebra, that's equivalent to saying that we, quote, start at different y-intercepts, but have the same slope. However, you could also have two lines, two linear equations, that when you graph them are actually the same line, not two different lines. So, for this last one for now, rather than trying to solve at first, I want you to see what happens when we rewrite each of these in slope-intercept form. On each of them, we'll have to subtract the x term first. And then we will have to divide by the coefficient of y. Remember to, quote, distribute that division and to reduce. So the first one we get y equals negative 5 fourths x plus 2 over 4, which reduces to plus 1/2. On the second one, dividing negative 20 by 16, we can reduce that to negative 5 fourths. And we can reduce 6 over 16 to 3/8. Remember that if you're using an online homework system, besides reducing, you will probably have instructions to use integer or fractional coefficients, not to write them as decimals. We've got the same slope, but different y-intercepts. These are the y-coordinates of the y-intercepts. So we are looking at parallel lines. In the wording of the question, that means that there are no solutions. I'm going to take this a little bit further. The similar question that I worked this around, the similar question I found from a textbook, said don't actually try to solve the equation, this system of equations. Let's go back. Let's do that. Let's see what happens as another way to recognize when we have no solutions. Five goes into 24 times and 4 into 16, the same number of times. I can multiply the first by negative 4. Distribute on the left. Don't forget to multiply to the other side as well. And I've left the second equation alone. You know you're dealing with a special situation of parallel lines So no solutions, or same line, every XY ordered pair that works for one equation will work for the other, because really those are just two equations representing this very same line. Here, both of these cancel out. Remember that you'd be left with 0 on that side. But when we add on the right, we get -2. And obviously those aren't equal. That's our clue that when we solve by elimination or even substitution, if all the variables cancel out, and we're left with unequal numbers, then there are no solutions. And for the moment, in terms of what I'm filming, I'm going to leave this as a question. How would you tell when solving by substitution or elimination if you're dealing with what would be the same line on a graph? How would we tell by substitution or elimination that we're getting infinitely many solutions instead? That's all for now, and I'll see you again real soon.